Hi, welcome to the pre-calculus lecture series. And we are in the chapter 6. And we are going to talk about the trigonometries over the right triangle. So in the section 6.1, we have defined how the angle measurements, the radian versus degrees, right? And how it's the radians defined. So in the section 6.2, we're going to specifically talk about the trig function over the right triangles. So instead of use the real value defined by trig function, like the one unit, use the unit circle methodology approach, we're going to use the right triangles approach to define the trig function. In fact, they are very similar and the same property that all follows here. Okay, so let's go ahead and go to take a look at our lectures notes here. Okay, so we said how do I define the trig function by using the trigonometry ratios here. Okay, so from the right triangle. So the first, let's take a look at the right triangles here. Okay, so if this is my right triangle and this is my angle theta here, right? And then here, the one face the 90 degrees. So this is my 90 degrees angle. So the one face this 90 degrees, we call this the hypotenuse. And the other ones here, the one that face the theta, we call it, this is the opposite side. And the one, the right next to this theta, we call this the adjacent side here, okay? So the 6 trig functions we have is like the way we define is the sine theta. So we defined is the opposite over what is the hypotenuse, right? Then the cosine theta we defined is adjacent over hypotenuse. Then the tangent theta we define is the opposite over adjacent. And then after you define these three, the remaining three will be pretty easy because the remaining three, just the reciprocal of this one. So like then the sine, the reciprocal of the sine is cosecant theta. So basically you just flip it. So this is a hypotenuse over the opposite. Then the cosine theta, we say this is the secant theta is over the hypotenuse over the adjacent, right? And then the cotangent theta is equal to the adjacent over the opposite here. You know, when I was young, I have like a kind of the way to, kind of remember these definitions. So the signs, right? Because here's the theta. So the sign, so the way I remember, like this is S, right? So it's opposite over hypotenuse, right? Then for the cosine, I use this notation. I say cosine, this is kind of like a C, right? So it's a C, so it's adjacent over hypotenuse. Then for in the tangents here, the way I remember is like this is the T's, right? So it's a T, so like a tangent, so it's opposite over adjacent. That's just a quick way, you remember. And like we talked before, this is the same way like you define in the unit circles, right? Is the y, sine is the y's, right? And the cosine is the x, and the tangent is 1 over x here. Okay, so that is like a kind of a shortcut way for me to remember. Different people, different teachers, they might teach you the different way to kind of help you to remember these 6 definitions here. Okay, so now let's take a look at the first one. It's pretty easy. They say find the 6 trig functions definition. So take a look here. This is my what? This is my theta here, right? The theta is over here, right? This angle is here. Okay, let's try to see here. So the sines here, right? Sine, like we say, is S here, right? So it's a 2 over what? 2 over 3. And the cosine theta here is like a cosines, right? So it's what is 3 and the square root of the what? Square root of the 5 over 3. Then the tangent theta here is like what I said, we say we can remember easy tangent theta. So it's 2 over what? Square root of the 5. Then after you get the first 3, then remaining 3 is just a reciprocal. You just flip it. So the cosecant theta is equal to the 3 over 2. Then the second theta is equal to the 3 over square root of the 5. Then the cotangent theta is equal to the square root of the 5 over 2 here. Okay, so that's pretty, I think it just basically used the definitions here. So now the example number 2 they say if a cosine alpha is equal to the 3/4, sketch a right triangle with acute angle alpha, find the other 5. Okay, so here basically we say, okay, right? So this is my alpha, right? So cosines, right? So is what is adjacent over hypotenuse. So the 3/4 here is the adjacent over the hypotenuse, right? So what is my adjacent here? Adjacent is 3. So what is my hypotenuse here? My hypotenuse is 4 here, right? Okay, then in order to find these angles here, so what I need to do is here, I need to use the Pythagorean theorem, right? Because the Pythagorean theorem tells me this square plus this square is equal to 4. So I know 16 the square, I'm sorry, not the 16 square, it's 4 square is equal to 16, right? So we know the 4 the square is equal to what? 3 square plus here, let's say it's y square. So what is here is 16 equal to 9 plus y square. So what is the y square? So I can say the y square is equal to what? 16 minus 9 is 7. So y is the square root of the 7. So I know this side is the square root of the 7th here, right? So after that, now I will know. So I say, okay, now I can say sine alpha. So what is the sine alpha? Is opposite over hypotenuse. So it's 7 square roots and 4. Then cosine is already given. So cosine alpha is equal to the 3/4 here. And then the next ones here is the tangent alpha. Tangent alpha is opposite over adjacent. So it's the square root of the 7 over 3. Then this is just reciprocal. The remaining 3 is cosecant alpha is what is 4 over square root of the 7. So what is the reciprocal of cosine is secant alpha. So it's 4 over 3. Now what is the tangent called? It's cotangent, right? So it's 3 over square root of the 7th here. Okay, so it's pretty simple. Basically, if you know the two sides, then you can use the Pythagorean theorem to find you the next one. Okay, so now this is probably the most important part for this section. We have the special values for the trig function. That means I have a special triangles here. The first triangle, the number 1 special triangle, okay, is what we call it is 30, 60, and then 90s here. Okay, so we can have so that means the triangles here. Okay, of course, this is what? Of course, this is 90s, right? So for this degree, these angles here, this is 30 degrees, and this angles here, this is like what? 60 degrees. Let me try to, okay, so let me try to write it inside instead of get a confused. Okay, so this one's here. This is, let's say, this is my 30 degrees angle. And then this side here, this angles here, the green one, let's say this is my 60 degrees angle. Okay, don't forget my degrees here. Then we can have so the special angles here, right? So this is 30, 60, 90. So the ratios here, we can have So the side faced 30 degrees angle is 1. So the hypotenuse is always is a double of the 1. Now here, this ratio is the square root of the 3 over 2 here. Okay, so some people, so so this is one, like the people will like to use it, and some other people, for the special angle, what they do here is like, let's say this is the 30s, right? And this is the 60s, right? Okay, so it's either way the same, the ratio is the same. So if this angle, this is a 30 degrees angle, this is a 60 degrees angle, of course, this is right angles, right? So some people, instead of put the hypotenuse is 2, they put it is 1. But then the ratio should be the same. The 30 degrees to the hypotenuse always 1/2. So here, this is what? 1/2, right? Then here, instead of square root of the 3, this one is the square root of the 3 over 2. It's faced 60 degrees angle here, okay? So that's why, when you try to remember, so those are the special value of the trig functions here. Okay, so from here, then you can know in here. So let's try to put like some special values here, right? So we talked this before. So if this is theta in degrees, right? So like in here, if you have 0, 30 degrees, and okay, so the 30 degrees, 60 degrees, here's 45 degrees. I'm going to talk about that later. And this is 90 degrees, right? So the sine theta and the cosine theta. And so tangent, I'm not going even to put here because you can kind of find the reciprocal, or if you want, we can do that. Okay, so now then you can see the sines, this is 0, right? So sine 30 is the opposite over the hypotenuse. Sine 30 is 1/2. The sine 60, right? The opposite over the hypotenuse, 60. So it's the square root of the 3 over 2. I'm going to go back here to feel the 45 after we do the next ones here. Then the 90 degrees, this is 1. So the cosines here is the same things here, right? So cosine 0, this is 1. Then cosine 30, look here, the hypotenuse, right? So the cosines go this way, right? So this is what? Cosine 30, I'm sorry, so with 30s, right? So cosine 30 needs to go this way, so cosines here. So the cosine 30 will be what? It will be the square root of the 3 over 2. I'm going to save this one. Then cosine 60, now we can say cosine 60 is this way, so it's 1/2. Then cosine 90 is what? It's 0s, right? So now we said, we know the tangent is what? The tangent is sine over cosines, right? So here, this is really equal to the sine over cosine. So we don't really need to write it. So sine over cosine, 0 over 1. So this is 0. This is 1/2 over square root of the 3 over 2. Now, what you do here, so you flip it, right? So this will be the 1 over square root of the 3. Sometimes people like to simplify that to the 3 to the 3. I'm saving the 40 here. I'm save this space here, right? So we're going to come back here to fill in this space. And then the sine tangent 60 is the square root of the 3 over 2 over 1 over 2. So this is square root of the 3. Then tangent 90 is sine over cosine, so 1 over 0. So this is what? Undefined. Yeah. Okay, so this is the special angle for the special triangle 30, 60, and the 90s here, right? Okay, so we have another special triangles here. So the another special triangles here is the number 2 special triangle. Okay, so the special triangle, this is, we say, is 45, 45, and then 90 degrees. So that means in here, I have these ones here, right? So this is my theta. this is my, let's say here, 45, 45, right? So that means this angle is 45 and this angle is 45, okay? Okay, so this is, we call this the 45, 45, and 90. Of course, this is 90, see here. Okay, so if you want, you can say this is, you know, both of them is 45, right? Okay, so for the 45, 45, the way you can write it, you can put each leg is here is 1, 1, and you Pythagorean theorem. This is the square root of the 2. Or some people, they will prefer, you can put, some people, they prefer to put the hypotenuse as 1 here. So this is a 45 degree, this is a 45 degrees. And then this is my right triangles here, right? So instead of put the square root of 2, some people like to put the square root of, put 1s here. Then here will be what is the square root of the 2 over 2 and the square root of the 2 over 2. So for either one, it will work, all right? So let's go back to the, okay, so we said the special angles here, right? So we have this 45 degrees here. We have not doing that yet. So this is 45 degrees. So I have a sine theta, cosine theta, and tangent theta, right? So I'm just trying to fill this yellow one. So sines, right? So sine is like we say, sine, you can do like this, right? So sine is what? It's the square root of the 2 over 2. Then the same way cosine is here, it's the square root of the 2 over 2. Then the tangent is sine theta over cosine theta. So it's what? It's 1. Okay. So this is very, very kind of the important, you know, you can always derive it, but if you remember those special triangles, and then you will be able to get the answer a lot faster. Okay, so now the next thing's here. So I want to, instead of, okay, so let's do the example number 4 first, right? So I want to solve the triangles here. Hey, take a look here. We have a special angles here. It's the 30s, right? So then the hypotenuse here, the hypotenuse is 12. So I know, so if this is 30, what is this angles here? This angle B has to be 60 degrees, right? So I know the angle B has to be the 60 degrees, right? Because the whole triangle is 180, this is 90, so B has to be the 60. Okay, then the side A, remember the 30, 60, 90 are the special. The side A is here, right? So this is the side, the face, the small angle, 30 degree. So side A is what? A is 1/2 of the what? The hypotenuse. So it's 12 over 2, so it's 6. All right, okay. Now the B's here, like we did the graphs here, take a look, see here, right? So B here, if you treat the hypotenuse 1, the B is the one facing the larger angle, the 60-degree angle. So it's the square root of the 3 over 2. So my B's here will just be the what? It's the square root of the 3 over 2, the hypotenuse, right? So then you will be able to, so this is the square root of the 3 over 2 times 12. So it's a 6 over square root of the 3 here. Okay, so this is how do we use the special triangle, because this is the special triangles here. Okay, so now let's take a look at the problem number 3 here. The reason why we want to use problem number 3 is just that I want to show you how to use your calculators, right? So make sure your calculator setting. So what do you need to set here? So because this is a degrees, right? So you need to make sure your calculator setting is the degrees here, okay? So you can use this example and try to check, put the number into your own calculator. to see, you will match my number or not. If you do, then you are, you do the setting correctly. So for the first one, tangent 40, this will be very close because it's always go to like the many decimal points. So it's pretty close to the 0.839. Okay, so you can check it to see you will be able to get that. Then the cosines here, right? So you put the cosine 20, and let's see what we have here. So cosine 20, you will get a number is 0.9397. Okay, so the cotangents here, most of the calculator does not have a cotangent. So what you can do, I know the cotangent and the tangent are the reciprocal. So cotangent is 1 over tangent. So you put a tangent 14 here. Okay, so you will get a tangent 14. This is 0.2493. Then you take the reciprocal of that. So what is the answer here? It's 4.0107. So the cosecant is the same. Typical, most of the calculator typical does not have the cosecant, but I know the cosecant is the sine reciprocal. So you put a sine 80, right? So sine 80 will give you number is like a 0.984a, very close to this number. And then you take the reciprocal of it, it will give you 1.01543 something, right? So make sure you use your calculator. It doesn't matter what type of the calculator you have. The purpose for this example is make sure you know the, okay? So that is make sure you know how to change your calculator settings here, okay? Okay, so now the next definition is a very kind of important definitions, and we use that a lot in the application. And so in here, we're going to talk about the angle of the elevations and the angle of the depressions here, right? So angle of the elevation is basically you look up the things, right? So if you are standing here, okay, and then, for example, here is a bigger trees here. Okay, so here is a big trees here, right? So there is a bird, so here, like if there's a bird nest here, let's say here, there's a bird nest here. So you are standing here, you look up, right? So you look up to this bird nest, your eyesight. So your eyesight and this horizontal ground, you are standing here. So the angle you form is here, okay? So the angle you form here, this is what we call the angle of what? This is what we call, this is the angle of the elevation. Okay, so that's why we call it is the angle of the elevations here. All right, so the reason why we said we can use it, and because that's why we're going to use, like in the older time, they don't have the, so if how do you estimate, if a tree is very big, right? So how do you estimate the height of the tree? You can use the trigonometry here. All right, so what is the angle of the depression? So the angle of the elevation, you look up, right? So the depression is you look down, okay? So for examples here, you are standing, right? So you are standing at the top of a cliff, then you saw a little, let's say here, a little dog here, right? So if you see a little dog here, then in here, you look down here, right? So you look down. So you say, hey, your eyesight here, right? So your eyesight, you look down here, right? So then we know, okay? So then when you look down here, right? So then this angle's here, right? So it's from the horizontal line, you look down here. So this angle, we call the what? We call this is the angle of what? Depression. Then we can use our trig function definition to find. So if you want to see how far the dog is from the, the cliff here, right? So then you also like you can estimate how tall is the tree or how tall is the buildings here. Okay, let's take a look at our last examples here. The last example is showing you a giant redwood tree casts a shadow 532 feet long. Find the height of the tree if the angle of the elevation to the sun is like the 25.7 degrees here, right? So like here, if this is the trees here, right? Then the sun is here, then you cast a shadow here, right? So like say here, this is the shadow of the tree. Okay, then we say the angle of the elevations. That means if you look at the treetops here, right? So here, so this is the angle of the elevations here. So it tell you, hey, this angles here is what? Is 25 point what? 25.7 here. So what I'm looking for, I'm looking for is the height, right? So I'm looking for is the height of the trees, right? So let's say the height is h here. Okay, so now I know, okay, so the h is here, right? So I'm looking for this. I'm finding the h. So what is the h is here? So the shadow, I know the shadow here, the shadow is 532, right? I'm finding this, I'm finding here, I'm finding this values here. So which trig relations use these two things here? I say, oh yeah, height and shadow. So it's opposite over what? Adjacent. So I know that the shadow, so opposite over adjacent. What is that? That is the tangent for what? 25.7, right? So that is the tangent theta. So that will be the tangent 25.7 here, right? So what is the opposite? Is the height. What is adjacent? The adjacent is the shadow. It's 532. Then you use your calculator, take a look. What is the tangent 25.7? It will be 0.4827 from here to here, right? You use the calculator. So this will be h to the 532. So what is the height here? Height will just be the 532 times the 0.48127. And so what you get the height of the tree is approximately to 256. Okay, so this is the very, so that's why, this is the very wide applications about the trig functions, right? So this is why in this section, we're defining the trig function of a right triangle. And so if you put the right triangle back to what the, your unit circle is the same definition. It's just a unit circle, your hypotenuse is 1 here, right? So it's kind of like a, the very similar things like we did in the, like we did in the chapter 5. So the two key things we need to learn in this section is the application part. So what is the angle of the elevations and the angle of the depression? Then the next things here, like I said, the most important ones here is those special triangles, right? 30, 60, 90, and the 45, 45, 90 degrees triangle. Those are the two key topics in these sections here. Okay, that's it. And very nice to talk to you about this. And so hope you find this section is pretty easy because it's very similar like what we learned before. Okay, that's it. And looking forward to talk to you to our next talk to you to our next sections here. Okay, bye.